How's it going, everybody? It's time. It's time for you to upgrade to a general amateur radio license. And this playlist and all the videos there within are to help you do that. We're trying to break up the sub-elements, the sections, if you will, of the amateur radio general license question pool into these video groups. So if you take the link in the video description to the playlist, you can go in order, or I guess in any order you want. But please start at intro if this is the first video you're watching so you understand what the heck is going on. You will need to have your technician amateur radio license first before you upgrade to general. Yes, you have to take them in order. You can take them all in one sitting, but you got to start at technician, then general, then extra if you want. So general is the middle license. It gives you a ton of access to the HF frequencies, and we are studying via hamstudy.org, a free website where you can make an account. You can team up with your friends to study your general license or your technician if you don't have the general yet, and you can take practice exams, and those practice exams will keep track of how you're doing and will give you questions in areas that you need a little bit more help in. But for today's video, we are using the iOS application. There's also an Android application, and I will have links in the video descriptions for them. We are under General, so we're going to click that, and then we're going to read the questions. And today we are on G4, G stands for General, Amateur Radio Practices. So let's start right there. Oh, it is broken up into 5 sections within sub-element G4. So let's start with station configuration and operation. G4 question 1. What is the purpose of the notch filter found on many HF transceivers? And it's B, to reduce interference from carriers in the receiver passband. Now, keep in mind, a notch filter is looking to notch out a very spiky signal that you're receiving. Often, an example that's used is cars with internal combustion engines will have ignition coils, spark plugs, that kind of thing, and they can sometimes create a burst of energy that is very spiky. And a notch filter is perfect for that because it'll lay over the top of that spiky region and null it out. Some radios have auto notch filters, which can be very nice. And so you're going to use a notch filter for something, again, that's like a single high-pitch, narrow bandwidth tone, like maybe Morse code, like if somebody just held the key down and you hear beep, throw the notch on that, it nulls it, and you can still hear single sideband communication. That's when you use it the most. Question 2, what is the benefit of using the opposite or reverse sideband when receiving CW? C, it may be possible to reduce or eliminate interference from other signals. Yeah, so CW, right, Morse code, you're generally going to have a small filter space that you're going to be operating on. And there could be, somebody that's relatively adjacent that you're picking up other signals on. So you can flip the sideband, in some cases with some radios, and that might help you out, get your signal, at least to be able to receive a little bit better. Question 3, how does the noise blanker work? C, by reducing receiver gain during a noise pulse. Now, noise blankers, in my experience, are something that you'd use to kind of soften a noisy area where you might get some pops and crackles that are relatively wide-banded. They are not a cure-all, and just remember that anytime you put a filter or some kind of processing on the signal, it's going to generally kind of reduce the overall signal strength that you're trying to listen to. So if it's a voice and they're kind of in the noise and you think, oh, I'm just going to hit the noise blanker and that's going to take away the noise. Well, no, the signal you're trying to hear is a part of that noise. So sometimes, even though it can be a little abrasive on the ears, it's best to try to not use any filtering first before you try and turn on the noise blanker or see if you can improve it via some kind of audio processing, at least to train your ears a little bit. All right, question 4 is going to throw something at you that you might not have heard about before. They're going to start talking about something called plate, and later we're going to hear grid. Now, these terms are related to vacuum tube amplifiers, and you might be thinking, vacuum tubes? That's old technology, right? Well, so kind of yes, but also the amplifiers we use in amateur radio, some of them still use vacuum tubes. They're available cheaply, and they work just fine. There is a bit of a tuning process to them, though, and you literally go in and you adjust a tuning knob to adjust the grid and the plate and kind of back and forth until you get it zoned in, and then it will effectively amplify your signals. So that's what question 4 is talking about. What is the effect on plate current or the correct setting of a vacuum tube RF power amplifier's tune control? And you get a pronounced dip. So generally when you're tuning the grid, when you're tuning the plate, you need to dip it down for its current that you see on its power draw. We're going to hear about the the grid in a second, but just keep in mind, and there's a bit of explanation because I don't have a tube-based amplifier anymore. But with that said, a pronounced dip or drop in the reading on the plate current meter of a vacuum tube RF amplifier shows that you have a correct adjustment of the plate tuning control. This dip happens when the impedance is matched at the right frequency. So there you go. You're tuning for the right frequency, you dip the plate, and you're ready to go, at least to go tune up the grid. Question 5, why is automatic level control used with an RF power amplifier? This is an important one. A lot of amplifiers will have an ALC plug, which will help you to prevent excessive drive. Now, drive is the RF power that your radio is putting into the amplifier. There is a certain level you want to give your amplifier so that you don't overdrive it and potentially damage it. And the ALC control will help you prevent damaging it via excessive drive. Question 6, what is the purpose of an antenna tuner? Now, I don't want to turn this into a big diatribe, but antenna tuner is a word that I think a lot of people are trying to get away from. We're calling them trans matches now, or transmitter matching devices. But an antenna tuner is so steeped in kind of the lore of amateur radio that we use it just nonchalantly, even though it's not physically tuning the antenna, right, everybody? So keep that in mind as we go to the answer here. C, increase power transfer from the transmitter to the feed line, right? So it's not doing anything to the antenna. It's helping to match the impedance seen at the feed line to the antenna to the transmitter, which is expecting 50 ohms, okay? Question 7, what happens as a receiver's noise reduction control level is increased? And A, received signals may become distorted. So there's a processing step that happens to the received signal before it goes out to your ears via headphones or the speaker. And noise reduction is one of those kind of filter processing things that you can do. And they generally have like a 1 through 10 value, or maybe even a 1 through 100 value. But as you start going higher up that scale to try and help reduce the noise, the processed signal, the signal you're trying to hear, can also become distorted. So there's a game to play there. There's a balancing act that if you hear a signal way down in the noise, you might want to try pull them out with just your regular ears first, and then start slowly stepping up the reduction, the noise reduction, until you may be able to hear them a little bit better. It's kind of like using salt and pepper. A little bit goes a long way, and you don't want to use too much because it'll mess with the taste of your food or the sound of your signal. Question 8, what is the correct adjustment for the load or coupling control of a vacuum tube RF power amplifier? And it's D, desired power output without exceeding the maximum allowable plate current. Again, these are things that revolve around tuning a vacuum tube amplifier. And it's a part of an aspect of amateur radio, although tube amplifiers are becoming less popular these days, but it is D, just remember, desired power output. 9, what is the purpose of delaying RF output after actifying a transmitter's keying line to an external amplifier? C, to allow time for the amplifier to switch the antenna between the transceiver and the amplifier output. This is an important step if you think about pushing RF through like a hose. When you have a transmitter that needs to produce drive to key the amplifier and then have it amplify signals, there are some amplifiers that just handle it. You just throw the power at it, it knows when to switch over, or it's RF sensing. It actually senses the RF coming in, it activates, and then, bam, goes down the pipe. In a lot of amplifiers cases, though, it doesn't. And so you usually want to add a bit of a delay between when you PTT to talk and then when the actual transmitted power goes from your radio into the amplifier. Give it a little bit of time for the amplifier to catch up and to get ready to amplify your signals. So that's generally why we do it. It's not always needed, but it's always a good idea to consider that you may need to use it, and probably should start there. It also really doesn't affect your output signal. Question 10, what is the function of an electronic keyer? And that's B, automatic generation of dots and dashes for CW operation. These are very handy, particularly if you've ever done a Parks on the Air activation or Summits on the Air activation. You can just hit a button and it goes CQ, CQ, Summits on the Air, IM, and then your call sign, in my case, KI6NAZ, right? And you can just hit that over and over again and it'll keep transmitting. And in some cases, they're smart enough to go onto a delay, like they'll wait 10 seconds and then they'll transmit the same thing again. Very handy, saves you a little bit of back and forth with your hand, and it makes the activation a little bit more enjoyable. There's voice versions of that too, voice keyers. Question 11. Why should the ALC system be inactive when transmitting AFSK data signals? AFSK is a type of digital mode that we use when transmitting between radios. And it's B, the ALC action distorts the signal. ALC stands for automatic level control. And so when you're doing voice communication, an ALC will help you not blow up the front end or distort the microphone by overdriving it with too loud of a voice like I have. So ALC will help kind of bounce back and forth and soften that. But it's not good for AFSK signals. It could distort your audio, your transmitted data at the output of your radio, causing some emissions or maybe data changes that you didn't expect. So we generally will leave ALC turned off, automatic level control. With that said, radios have gotten a lot better at this, and so there's less of this problem in newer radios. Just know that it is something to keep in mind if you're having weird problems with having distorted signals or you're not making a lot of contacts. You might want to think about what your ALC is doing and tune that back in a little bit or bring it down some to not mess with your radio transmissions. Question 12. Which of the following is a common use of the dual VFO feature on a transceiver? And it's C, to transmit on one frequency and listen on another. That's it. So like a handheld, like a handy talkie, I will have National Simplex on channel A, and then channel B, I'll have a repeater. And you can do the same thing with HF. You can listen on one band, maybe it's your buddies talking, and then on another band you could be chasing, or channel, should say. Dual VFO often is referred to like channel A, channel B. You could be listening to a DX expedition that's getting set up, or maybe in the setup in the future. Or you may be looking for a frequency that a known DX station hops onto, and you're waiting for that gray line to pass overhead, allowing you to be able to hear them. There's all kinds of reasons why you might use a dual VFO. Question 13, what is the purpose of using a receive attenuator? And that's A, to prevent receiver overload from strong incoming signals. Very true in older radios, although it's still something you should do in newer radios, is to use an attenuator. I happen to live in an area with a lot of RFI, meaning my noise floor is very high, which sadly means that there's some signals that get dropped below the noise floor. But to help your radio do its best job, it's best to take that noise floor and lower it down, attenuate it, so that the receiver can focus on the signals that are coming above that noise floor and just do a better job of presenting them to you in the audio quality that you get. So you should use an attenuator when needed, not when possible, but when needed, to help bring that noise floor down to prevent receiver overload. All right, so that is Section A, so we're going to switch to B of sub-element 4. Question 1, what item of test equipment contains horizontal and vertical channel amplifiers? That is A, an oscilloscope, which is a vital test tool that you may use, but it's not always needed. People generally will use a spectrum analyzer more in their amateur radio journey than an oscilloscope. But it does have its use cases, and they are important, so you may use one in the future. Question 2, which of the following is an advantage of an oscilloscope versus a digital voltmeter? D, complex waveforms can be measured. So we can use an oscilloscope to measure audio, for instance, like how a sound signal or signal is being processed, and we can see it on the oscilloscope readout, which is different from a digital voltmeter, which is just going to give you a straight up number on its readout. Question 3. Which of the following is the best instrument to use for checking the keying waveform of a CW transmitter? And that's A, an oscilloscope. So that's true. That's a very good use case. So if you're doing Morse code and you want to test the keying waveform of what your output looks like, you're going to use an oscilloscope for that. Question 4, what signal source is connected to the vertical input of an oscilloscope when checking the RF envelope pattern of a transmitted signal? D, the attenuated RF output of the transmitter, right? Don't go blowing the whole thing up, but you want the attenuated RF of the transmitter. So let's read a little bit about that. The attenuated RF output of the transmitter is connected to the vertical input of an oscilloscope when checking the RF envelope pattern of a transmitted signal. This allows you to check for signal distortions. That's why you would do this. Memory tip: output in the answer corresponds to the input in the question. Question 5. Why do voltmeters have high input impedance? So that's D. It decreases the loading on circuits being measured. So very high impedance means that it's not being considered by the circuit, so it can continue to measure, and that the circuit doesn't acknowledge it so that you can still get a good reading. Question 6. What is the advantage of digital multimeter as compared to an analog multimeter? And it's C, higher precision. So digital is going to give you higher precision in numbers. Analog's still cool, little swinging needle. I grew up with one of those, but at the same time, digital's probably where it's at nowadays. Some people will disagree. There's certain reasons why you want an analog versus digital, but it's not for this video. Question 7. What signals are used to conduct a two-tone test? And it's B, two non-harmonically related audio signals. Let's hit the explain, because I know this is going to be new for a lot of you. A two-tone test uses two non-harmonically related audio signals to test the linearity of signal amplitude in a single sideband transmission. The two tones of equal power are put into the microphone input, and the waveforms are examined for linearity using an oscilloscope. So input in two-tone, output into the oscilloscope, and you can do a two-tone test. Question 8. What transmitter performance parameter does a two-tone test analyze? We read about that already. It's A, linearity. Question 9. When is an analog multimeter preferred to a digital multimeter? Hey, I guess it is this video we're going to talk about this. D, when adjusting circuits for maximum or minimum values. So that is when you want an analog over a digital. Question 10. I totally forgot that question was in this pool. Which of the following can be determined with a directional wattmeter? A, standing wave ratio, which you're probably going to have a lot of involvement in that when you get to HF and you start playing around with antennas. An important thing, standing wave ratio. It's an abbreviation, or it is abbreviated by SWR. Question 11. Which of the following must be connected to an antenna analyzer when it's being used for SWR measurements? C, antenna and feed line. This is all about antennas. You literally are going to be doing a lot of this if you're setting up your own home HF antenna. Question 12. What effect can strong signals from nearby transmitters have on an antenna analyzer? B, received power that interferes with SWR readings. Yeah, this can be difficult during field day if you got a lot of people keying up on very similar bands or adjacent frequencies. That can mess with your analyzer. Question 13, which of the following can be measured with an antenna analyzer? The impedance of coax cables. Yeah, so feed lines and antennas, anything that's about getting your signal outside of your radio is going to be helpful to have an antenna analyzer. It's probably one of the first tools that you should consider as you start your journey into HF, high-frequency radio. All right, we finished section B, on to C. Question 1 in section C of subelement 4. Which of the following might be useful in reducing RF interference to audio frequency circuits? B, a bypass capacitor. What the heck is that? A bypass capacitor takes in extra noise or radio frequency interference in the system and filters it out. That could be very helpful. Question 2, which of the following could be a cause of interference covering a wide range of frequencies? C, arcing at a poor electrical connection, particularly like a power line outside your house. I experienced this and had to have the power company come out and fix it. This is an extremely difficult form of interference to operate radio around. It makes your noise floor go through the roof, and receive signals become almost impossible. Now, this can also happen with just a simple device in your home. And the adjacency to your radio can make this as bad, if not worse in some cases, like a power line outside. So arcing, literally a spark jumping between two wires, creates a lot of radio frequency radiation, which your radio will pick up and it'll just be like massive noise force. So keep that in mind. Can be really difficult. Question 3. What sound is heard from an audio device experiencing RF interference from a single sideband phone transmitter? C. Distorted speech, meaning RF is getting into the microphone when the person is talking, and it creates really distorted, nasty sounding audio. Question 4. What sound is heard from an audio device experiencing RF interference from a CW transmitter? On and off humming or clicking, literally in the form of Morse code. You might even be able to pick up the actual characters if you listen to it, and that humming or buzzing will actually be an indicator of, hey, somebody's doing CW in the background. Question 5. What is a possible cause of high voltages that produce RF burns? D. The ground wire has high impedance on that frequency. And so what that means is you could be, energizing devices, even your microphone. Some people have actually gotten an RF burn on their lips from some situations, not all situations, regarding with how their station is set up and how they're doing grounding. So it's important to always focus on grounding, particularly in the home station, and make sure that you're using the appropriate wires to do so. Question 6. What is a possible effect of a resonant ground connection? C. High RF voltages on the enclosures of station equipment. Yikes. Yeah, so touching the radio if you're transmitting could actually cause an RF burn. Again, I mentioned, touching your lips on a connected microphone. It could be energized with RF energy, and you could get an RF burn from that. Ground connections, very important. Question 7. Why should solder joints not be used in lightning protection ground connections? Okay. Boy, this is an easy one to remember. So solder literally becomes liquefied when struck by lightning and blasts all over the place. So it's A, solder joint will likely be destroyed by the heat of a lightning strike. Yeah, so we always use like a compression fitting, something you actually bolt down onto the wire for grounding. Just remember, solder melts and lightning melts most things. So question 8, which of the following would reduce RF interference caused by common mode current on an audio cable? A, place a ferrite choke on the cable. So you can see it actually. Here's a ferrite choke right here. A little clip-on thing with some metal epoxied. Basically, it is metal shavings or pieces of metal that are encased in epoxy, and we wrap that around cables to restrict common mode currents from flowing down that cable and causing audio issues. So this is something you may have to deploy on a number of wires in your shack. Just know that ferrite chokes are important. You may need to use them in certain instances, and they're a thing that are a part of every ham's life. Question 9. How can the effects of ground loops be minimized? And it's D, bond equipment enclosures together. Now, this is the right answer, but there's a bit of nuance, right? So when it's talking about grounding, something to keep in mind is that it's oftentimes good to have a central grounding location. In my case, I have a bar about, this big, flat piece of copper bar. And all my devices go to that bar, right? They're actually bolted to it, real strong connections, real tight connections. And then that bar is connected to my grounding system, right? Which leads to a grounding rod outside my home. Very important to have a good, well-bonded station, particularly at your house. Question 10. What could be a symptom caused by a ground loop in your station's audio connections? A, you receive reports of hum on your station's transmitted signal. Yeah, so if you have a ground loop, it's going to cause this noise to get picked up by the microphone element and be transmitted, and people will hear it on the other end on their radios, and they'll tell you about it. Sounds like you got a hum, or so you've got some kind of weirdness in your audio signal, and that's a sign that you have a ground loop. And a ground loop is caused by daisy chaining a lot of devices together via ground and causing other issues that way. That's why central location for ground and then out from there is the best way to go. Question 11. What technique helps to minimize RF hotspots in an amateur station? C, bonding all equipment enclosures together. Same thing, get a bar, bring them all to that bar, then handle the grounding from there. Question 12. Why must all metal enclosures of station equipment be grounded? D. It ensures that hazardous voltages cannot appear on the chassis. So there's the safety aspect of grounding. Very important. That completes section C. On to section D. Question 1. What is the purpose of a speech processor in a transceiver? A. Increase the apparent loudness of transmitted voice signals. So it's doing a bit of processing on transmission, and it'll do some work helping to peak and balance out different signals, and it goes out via RF, which can help in some cases get you a little more punchy to break through some pileups or get your signal out a little bit easier. Question 2. What does a speech processor affect a signal sideband phone signal? B. It increases average power. That is one of its major functions. Question 3. What is the effect of an incorrectly adjusted speech processor? Hey, it's another, all these choices are correct. D. It will show up as distorted speech, excessive intermodulation products, and C. Excessive background noises. That means you have an incorrectly adjusted speech processor. All those things could happen. Question 4. What does an S meter measure? You're going to hear this a lot. Your S9. I can hear you S9 on the air. Hopefully I get to say that to you sometime in the future. And that's C. It's your received signal strength. Radios, your radio that you may be looking to purchase will likely have some kind of a display with a little bar that's kind of a little curved to it, and that's going to be your S meter. That S meter is going to tell you what the signal is that your radio is receiving, and we use that to provide signal reports to the people that we are hearing on the air. Question 5. How does a signal that reads 20 dB over S9 compare to one that reads S9 on a receiver, assuming a properly calibrated S meter? All right. It goes, your S meter we just talked about goes S1 through S9, but then there's an upper stage, and it can go 10 over, 20 over, 30 over S9. But 20 dB over S9 in this case is D. It's 100 times more powerful. So there is a bit of an exponential growth or logarithmic growth to that particular 20 dB over the S9. So when you start dipping beyond S9, you're talking about big, big signals. You can often hear those stations with no background noise, no atmospheric noise in the background. They'll just be dead silent, like you're almost talking on a phone, or they could be standing right next to you. That's how clear it is. Question 6. How much change in signal strength is typically represented by 1 S unit? And it's A, 6 dB. So it's 6 dB to an S unit. Always remember that. 6 dB to an S unit. That is the measurement for an S unit. How much must the power output of a transmitter be raised to change the S meter reading on a distant receiver from S8 to S9? And it's C, approximately 4 times. Let's read into this a little bit. The power output of a transmitter must be raised approximately 4 times to change the S meter reading on a distant receiver from S8 to S9. Thus, for the reading on the scale to increase by 1 S unit, indicates that the signal strength has increased by 4 times, which corresponds to approximately a change of 6 decibels on a logarithmic scale. So keep that in mind. Every time you want to go from an S1 to an S9, you have to go 4 times up in power. Question 8, what frequency range is occupied by a 3 kilohertz lower sideband signal when the displayed carrier frequency is set to 7.78 megahertz? And it's C, 7.175 megahertz to 7.178 megahertz, 3 kilohertz wide. And you can see that in the representation of what's after the decimal point. Question 9, what frequency range is occupied by a 3 kilohertz USB signal with a displayed carrier frequency set to 14.347, upper sideband? So it's going from 14.347 to 14.350, and that's B. Upper sideband of the carrier or lower sideband. Depending on how you're watching this, that switches a little bit. But just remember, the higher frequency is the upper side, the lower frequency is the lower side. Question 10. How close to the lower edge of a band's phone segment should your displayed carrier frequency be when using 3 kilohertz wide lower sideband? And the answer is A, at least 3 kilohertz above the edge of the segment. So if the segment starts on 40 meters, it starts on 7.175, and you're using lower sideband, then your carrier frequency, the center frequency of which you're transmitting on, needs to be 3 kilohertz higher than that 1.75 space, the edge, if you will, the demarcation of the band for that low side. You got to come up a little bit off of it because your sideband is going to dip lower than your transmitted frequency. Question 11. How close to the upper edge of the band's phone segment should your displayed carrier frequency be when using 3 kilohertz wide upper sideband? So it's the same thing, but flipped. So if you're on the high side of the 20-meter band, that edge where your signal shall not go above, you need to make sure that you slide your transmitting frequency down by 3 kilohertz to make sure that you don't go above that and get outside of your transmit area. And that's B, at least 3 kilohertz below the edge of the band, the upper side of the band. All right, that was section D, moving right into section E. And I think this is the last one for sub-element 4. Question 1, what is the purpose of a capacitance hat on a mobile antenna? Aside from high fashion, a capacitance hat is C, to electrically lengthen a physically short antenna. And you may see these are like they could be little wire circles, and they show up as different things, but it allows you to get more wire in the air, basically, and they call that a capacitance hat. Question 2, what is the purpose of a corona ball on an HF mobile antenna? So think of a whip, and it's got a little ball on the top of it. What might that do? D, to reduce RF voltage discharge from the tip of the antenna while transmitting. So, bumping into something, create a little bit of discharge there, and the coronal ball helps prevent that. Question 3. Which of the following direct fuse power connections would be the best for a 100-watt HF mobile installation? And it's A, to the battery using heavy gauge wire. Now, make no mistake here. It's wanting to ask you, where should your power lines run in a mobile installation? And the answer is always going to be direct to the battery. Now, you could have a junction box just off the side of the battery where the wires connect to be able to get to that power, but you're almost always going to hear the recommendation of get those wires directly to the battery. That is the best possible situation, and heavy gauge wire is better in almost all mobile install situations. Question 4. Why should DC power for a 100-watt HF transceiver not be supplied by a vehicle's auxiliary power socket? Auxiliary power socket, back in my day, that was, the cigarette lighter location. You're talking about the 12-volt, circle. They call that the auxiliary power socket now. There's a very important reason for this, and it's B, the socket's wiring may be inadequate for the current drawn by the transceiver. Now, most technologies that use those big 12-volt plugs that you shove in the port, that's like, consumer electronics. It's not pulling a lot of current. Your radio, on the other hand, particularly like a 50-watt VHF UHF transceiver, that's going to pull a lot. And what it could do is it could heat up those auxiliary wires that go to the electrical system of your vehicle. And since you didn't install it, and you may not know what the spec of those wires is, you could actually create a fire. You could damage the system. You could melt the shielding off of it. You could rub against something which starts it on fire. Has that happened? Absolutely. Has people completely screwed up electronics in vehicles doing this? Yes, they have. That's why we say direct to battery, safest option. Question 5. Which of the following most limits an HF mobile station? C, efficiency of the electrically short antenna. Yes, particularly when you start talking about 40 meters, that's a really long vertical antenna. And so we oftentimes will use shorter antennas that have been loaded via coils of wire that we deploy, or we're using a special mobile antenna called a screwdriver, and they can manually slide up and down or automatically slide up and down. And those add more wire, add a longer coil to the whole setup, which gets you into those lower frequencies. And it's the efficiency of those coils that we're adding that is the biggest limiter on HF mobile installations. Question 6. What is one disadvantage of using a shortened mobile antenna as opposed to a full-size antenna? By the way, you can take the mobile off of this and the answer is going to be the same, right? Same answer. So even though it's talking about mobile, shortened antennas of any kind, whether you're adding a coil or whatever, will cause C, the operating bandwidth, to be limited. Meaning, if you add a lot of coils, inductors, you're bringing in the operating bandwidth space of that antenna, and you will have to adjust it more often. And it just so happens that that screwdriver antenna that we talked about that slides up and down, that's what it's doing. It's sliding up and down to change your bandwidth of where the antenna can efficiently or effectively be used. So yeah, keep in mind, shortened antennas will likely have reduced bandwidth. Question 7. Which of the following may cause receiver interference on an HS transceiver installed in a vehicle? All these choices are correct. There's actually more of those than I've seen the other way. A, the battery charging system. In my case, with an electric vehicle, they have 12-volt batteries still, and there's an inverter to go between those voltages. That can be a problem. B, the fuel delivery system. Yeah, so whatever injector setup you have, the power that actually drives that. And C, the control computers. The computers, the electronics in the vehicle itself can cause receiver interference. Fuel delivery will include the ignition system in this case, I'm pretty sure. I think that's what they mean. But yeah, all those can cause problems with vehicles. Hybrids also can have a lot of problems because they both have an electrical drive motor and a battery system, an inverter, and then they also have an internal combustion with its own ignition system. They can be really difficult for interference. Question 8. In what configuration are the most individual cells on a solar panel connected together? A, series, parallel. Question 9. What is the appropriate open circuit voltage from a fully illuminated silicon photovoltaic cell? And it is 0.5 volts VDC. 10. Why should a series diode be connected between a solar panel and a storage battery that is being charged by the panel? And it's D, to prevent discharge of the battery through a panel during times of low or no illumination. Now, the charge controller, solar charge controller, those little boxes, that's one of its primary functions, is to prevent the backloading of stored power in the form of a battery into the panel. Yes, if you connect a battery and a panel together and put the panel in the shade, the battery will heat that panel up. So make sure you always have some kind of a series diode or a charge controller to prevent such a thing from happening. Question 11, the last question in sub-element 4. What precaution should be taken when connecting a solar panel to a lithium iron phosphate battery? Hey, D, the panel must have a charge controller for reasons we already mentioned. Let's go back to this, G4. What was that last one? Mobile and portable HF stations, alternate and alternative energy source operation. Okay, that makes sense. Like, it's a lot of mobile questions. Why are we talking about solar panels? I don't have a solar panel on my vehicle, but hey, there you go. Guys, we've been using hamstudy.org, a free website that you can use. You can go to right now and start your journey, make an account, start taking practice exams, and you will become much more proficient in radio operation, at least understanding how it all works. This is a series of videos. There is a playlist that is in the video description. Please go check it out. If you have not already, please subscribe, because I'm kind of slow rolling these drops as we produce them, edit them, and make them available to you. If you found this video helpful, or the series helpful, I'd love it if you gave me a thumbs up. If you have not already, please subscribe, get notified when I post the next video. And if you like what I'm doing, like videos like this that take a little bit of time and a little bit of money to make, consider supporting on Patreon. I have a series of perks where you can get a free newsletter. You can help select the videos that I produce, including the live stream, the Patron Picks episode once a month, and you'll find a link in the video description to help support the channel. I'm Josh, KI6NAZ. Until I talk to you again for sub-element 573.